Hello, dear students. Today we have Proposition 12 of Book 3. If two circles touch one another externally, and the centers be taken, and those two centers be joined, listen to this. That line which joins those centers passes right through the point where those circles touch. What are the chances of that? Let's look at this here. Here we have two circles. The red circle and the green circle, and they're touching each other right there, one point, okay? Thus, it is required to show that when you take the center of each circle and you connect those 2 points with a straight line, that line will pass right through the point of contact. Quod erat demonstrandum. No, it's not about the imagination, it's about the intellect. We have to prove this. You know what? I don't think Euclid's did, but I certainly don't have a way to prove it directly, so I'm going to prove it indirectly through a reductio ad absurdum. Ready? Here we go. Let's get rid of this. And let's say that when you join the lines, it doesn't pass through the center, because I say that it does, Mr. Smarty Pants says that it doesn't. Okay, Mr. Smarty Pants, let me grant your position. I'm going to reduce it to an absurdity, so we're going to see that your position must be false, because if everything is logical and the conclusion is absurd, something in there must be false. Okay? So, let's say, Mr. Smarty Pants, that when you connect the 2 points, let these be the center, and then why don't we put this in black? Okay, continuing that one straight line, there we go, center and center. There we go, we just joined the centers and it passed through the circles where they don't touch. It passed at another place. Remember, it only touches at one place. Great, no problem, Mr. Smarty Pants, get ready. I'm gonna make you look dumb. Let's connect. I think I'm going to make you look dumb. Let's connect this point with the point of contact. Let's connect the center with the point of contact. And let's connect this center with the point of contact. Okay? So here we have the green circle and the red circle. And in the green circle, we have this green line equal to this green line. Why? Because they're radii of the same circle. Remember, this is the center. Therefore, these are radii. We know in any circle, all the radii are equal of that circle. Likewise, here in the red circle, this is the center, and these red lines are radii of that red circle. Therefore, they're equal to each other. Great. So let's do equals added to equals. I'm going to draw this out because it's a little bit hard to imagine. Okay, we know that these two are equal and these two are equal. These two are equal to each other. And these two are equal to each other. We know if we add equals to equals, the wholes are equal. So if we add these two to these two, okay, the wholes are equal. So this is equal. This and this are equal to this and this, okay? So this and this are equal to this and this. Let's add this. If this and this are equal to this and this must be less than this and this and this, because we added one thing to one side of the equation. They were equal, we put something else on the other side of the equation, now they must be unequal, with these two things being less than these three things, and these three things are this whole straight line. So in this triangle, these two sides are less than these two sides. But we know that in any triangle, two sides taken together are always greater than the remaining side. So these two are less than these and not less than these at the same time in the same respect. Okay, these two, for one reason, logic, are greater than this, and for another reason, Mr. Smarty Pants' position, that it doesn't pass through the center, shows them to be less than this. So we have a problem, right, Mr. Smarty Pants? That those two lines are both less and not less than that other line at the same time in the same respect. Absurd. Therefore, that position that you were holding, that when you join the centers, that it can pass through a point or points, which is not at the point of contact, must be false. If it's false that it doesn't pass through the point of contact, it must be true that when you join those centers, it passes exactly through the point of contact. Quod erat demonstrandum. Thank you. Bye-bye.